Welcome to the deep dive. Today we're diving into distributed storage systems.
Oh, yeah?
Cassandra and Bigtable.
Okay.
You want to know how they handle massive data sets, how they work, where they're used?
Yeah,
Buckle up, it's going to be a wild ride.
it really is. I mean, think about it. Today we're generating just an astronomical amount of data.
Yeah.
Everything from social media posts, financial transactions, to scientific research.
Right.
It's a deluge of data. And those traditional database systems,
Right.
they just weren't built to handle this.
It's like trying to fit the ocean into a teacup.
Exactly.
So how did these tech giants, Facebook and Google,
Right.
tackle this challenge?
That's where Cassandra and Bigtable come in.
Okay.
Both systems were born out of necessity.
Yeah.
Facebook, they needed a way to power its inbox search feature,
Oh, wow.
which was dealing with billions of writes per day.
Oh, my gosh.
Imagine trying to search through all those messages with a traditional database.
Right.
It'd be a nightmare.
And no kidding.
So Cassandra came to the rescue.
Okay, so Cassandra to the rescue, but it wasn't just about storing a massive amount of data, was it?
No, it's also about ensuring that data is readily available
Right.
whenever it's needed.
Yeah.
Think about services like Google Search or Facebook's newsfeed.
Yeah,
They need to be up and running 24/7,
of course.
even if parts of the system fail.
Right.
That's where the concept of distributed storage comes in.
Okay, so let's dive into that a bit.
Sure.
How do Cassandra and Bigtable actually achieve this incredible scale and reliability?
Well, they both use different approaches,
Okay.
but a key principle underlying both is data partitioning.
Okay.
Cassandra uses a technique called consistent hashing, where data is distributed evenly across multiple nodes in a cluster.
Okay.
It's like dividing a pie into equal slices
Yeah.
and giving each slice to a different server.
That makes sense. So if one server goes down, you don't lose the whole pie, just one slice.
Precisely.
Oh, okay.
And Cassandra has a clever way of handling nodes joining or leaving the cluster. When a new node joins,
Yeah.
it takes responsibility for a portion of the data from other nodes, ensuring that the workload is evenly distributed.
Okay.
This dynamic rebalancing is crucial for maintaining performance as the system grows.
So it's constantly adapting to changes in the system.
That's right.
What about Bigtable?
Yeah.
How does it handle data distribution?
Bigtable uses a slightly different approach
Okay.
with dynamic partitioning. It divides data into tablets,
Okay.
which are essentially smaller chunks of data
Okay.
that can be moved around and managed independently.
So it's a bit like having a giant jigsaw puzzle where each piece can be worked on separately.
A good analogy.
Huh.
These tablets are distributed across multiple servers,
Okay.
and Bigtable uses a clever three-level hierarchy
Okay.
to keep track of where everything is located.
Oh.
It's like having a super efficient library catalog
Right.
that instantly tells you which shelf and section to find your book.
That's impressive. It sounds like both systems have found innovative ways to handle massive data sets.
Right.
But how do they actually store and organize the data itself?
Well, let's get a little more technical.
Okay, yeah, let's get technical.
Both systems utilize a data model based on multidimensional maps,
Okay.
but they have subtle differences in their approaches.
Okay.
Cassandra, for instance,
Yeah.
uses the concept of column families, which are groups of related data,
Okay.
similar to tables in a relational database.
So it's a way of categorizing data within the system.
Right.
Okay.
Now, Cassandra offers two types of column families,
Okay.
simple and super.
Okay.
Simple column families are straightforward,
Right.
but super column families allow for nesting of data,
Okay.
creating a more hierarchical structure.
Okay.
It's like having folders within folders to organize your files.
And what's the advantage of that?
It allows for more complex data relationships
Okay.
and more flexibility in how you model your data. For example, in Facebook's inbox search,
Yeah.
a user ID might be the key. Words within a message become super columns,
Right.
and then individual message IDs containing those words are nested within those super columns.
Okay.
It's a very efficient way to organize data for fast retrieval.
That's really clever. It's like creating a highly specific index for searching through all those messages.
Exactly.
Okay, so how does Bigtable's data model compare?
Sure.
Does it use column families as well?
Yes, it does.
Okay.
Bigtable also uses column families as a basic unit of access control. But a unique feature of Bigtable is its use of timestamps.
Okay.
This means it can store multiple versions of the same data point,
Wow.
allowing you to track changes over time.
That's a fascinating concept.
Yeah.
Could you give an example of how that might be used in the real world?
Absolutely. Imagine a service like Google Docs,
Right.
where multiple people are collaborating on a document.
Yeah.
Bigtable can store each edit with a timestamp,
Okay.
creating a complete history of changes.
Yeah. This is incredibly valuable for version control, collaboration, and even auditing purposes.
That makes perfect sense. It's like having a built-in time machine for your data.
Exactly.
Okay, so we've got these incredibly efficient systems for storing and retrieving data.
Yeah.
But what happens when things inevitably go wrong?
Right.
How do they handle failures in the system?
That's where their fault tolerance mechanisms come in.
Okay.
Cassandra relies on a gossip-based protocol
Okay.
where nodes constantly share information about their status with each other.
Right.
It's like a neighborhood watch
Yeah.
where everyone keeps an eye out
Right.
and reports any suspicious activity.
So if a node goes silent, the others know something's up.
Precisely.
But how do they actually determine if a node has failed?
Cassandra uses a clever approach called an accrual failure detector.
Okay.
It's a probabilistic method
Mm-hmm.
that's much faster than traditional failure detectors,
Right.
which is crucial when you have thousands of nodes to monitor.
Yeah, of course. Instead of waiting for a specific timeout,
Okay.
it analyzes the frequency of messages from each node
Okay.
to determine if it's likely to have failed.
So it's a more dynamic and responsive way of detecting problems.
Exactly.
What about Bigtable?
Sure.
How does it handle failures?
Bigtable relies heavily on a highly available and consistent lock service called Chubby.
Okay.
Chubby acts as a central coordinator,
Mm-hmm.
ensuring that only one master server is active at a time,
Okay.
and managing metadata about tablet servers.
It sounds like Chubby plays a crucial role in keeping Bigtable stable and preventing conflicts.
Absolutely.
But I imagine even with these safeguards in place,
Yeah.
building and maintaining these systems must present some unique challenges.
Absolutely. Creating systems that operate at this scale
Yeah.
always comes with its share of
Yeah.
hurdles. One of the biggest challenges the Cassandra team faced early on was with their failure detectors.
Oh, really?
They realized that their initial implementations were too slow to detect failures in large clusters.
So their safety net wasn't quite as reliable as they needed it to be.
Exactly.
Okay.
To address this, they shifted to the accrual failure detector,
Okay.
which drastically improved their failure detection speed and made the entire system much more robust.
It's fascinating how they had to constantly adapt and innovate
It is
to keep up with the demands of a growing system.
And they also learned the hard way
Yeah.
that complexity can be a real enemy
Right.
when you're dealing with distributed systems.
Right.
Their initial tablet server membership protocol,
Oh.
which manages which servers are responsible for what data, was quite complex.
I can imagine that would lead to some serious debugging headaches.
You're telling me they ended up simplifying the protocol multiple times
Oh, wow.
to improve reliability
Yeah.
and make it easier to manage.
Yeah.
Sometimes the most elegant solution is the simplest one.
Right. It's a good reminder that less is often more, especially when you're dealing with systems at this scale. So we've talked a lot about the inner workings of Cassandra and Bigtable.
Yes.
But what about their real-world applications?
Yeah.
Where are these technologies actually being used?
Well, as you might imagine, both systems power a vast array of applications that we use every day.
Yeah.
Cassandra, for example,
Yeah.
has found a home in a number of services
Okay.
beyond Facebook's inbox search.
So it's proven its versatility beyond that initial use case.
Absolutely. It's being used for everything from content management systems to online gaming platforms.
Wow, okay.
Its ability to handle high volumes of writes
Yeah.
and its fault tolerance make it a great choice
Okay.
for applications that require low latency and high availability.
That makes sense. It's like a workhorse for handling those write-intensive workloads.
Exactly.
What about Bigtable?
Yeah.
We know it's used in over 60 Google products.
Right.
But are there any specific examples where its unique features really shine?
One compelling example is Google Analytics.
Okay.
Bigtable stores the raw clickstream data and pre-calculated summaries that power those insightful reports that website owners rely on.
That's a lot of data to crunch. I can see how Bigtable's scalability would be crucial there.
Absolutely.
Yeah.
And its ability to handle real-time queries is essential for providing those up-to-the-minute insights.
Are there any other Google products where Bigtable plays a critical role?
Another great example is Google Earth.
Oh, okay.
Think about the massive data sets of satellite imagery and 3D models that Google Earth manages.
Yeah.
Bigtable handles both the pre-processing of that imagery,
Wow.
and serving it to users as they explore the globe.
It's amazing to think that something as visually rich and interactive as Google Earth relies on a system like Bigtable behind the scenes.
It really is.
Yeah.
It's a testament to Bigtable's ability to handle both massive data volumes and low latency queries. Without it, the smooth and responsive experience we've come to expect from Google Earth wouldn't be possible.
So we've got these two incredibly powerful systems,
Right.
each with its strengths and unique features.
Yeah.
But as the amount of data we generate continues to grow exponentially,
Right.
what does the future hold for Cassandra and Bigtable?
That's a great question.
Will they continue to dominate the field, or will new contenders emerge?
That's a great question. Predicting the future of technology is always a challenge.
Yeah, of course.
But both Cassandra and Bigtable have strong communities and ecosystems supporting them,
Right.
which suggests they'll be around for a while.
They've also proven their ability to adapt and evolve over time.
Precisely.
Uh-huh.
But the world of data is constantly changing.
Right.
New challenges are always emerging,
Yeah.
and new technologies are constantly being developed.
So it's a bit of a wait-and-see situation.
It is.
But regardless of what the future holds,
Sure.
it seems like understanding the fundamentals of these distributed storage systems
Yeah,
is crucial for anyone working with data today.
absolutely.
Yeah.
These systems are foundational to so many of the services and applications we rely on.
Learning how they work and how to leverage their capabilities can give you a significant advantage in the data-driven world.
So as we wrap up this deep dive into Cassandra and Bigtable,
Yeah.
what are some key takeaways you think our listeners should remember?
Well, first and foremost, I think it's important to understand the fundamental challenges that these systems were designed to address.
Okay.
Handling massive volumes of data.
Those are some serious challenges.
Indeed.
Yeah.
And it's remarkable how both Cassandra and Bigtable have found innovative solutions to these problems.
Right.
Whether it's consistent hashing, dynamic partitioning, or sophisticated failure detection mechanisms.
Yeah.
These systems have pushed the boundaries of what's possible with data storage and retrieval.
It's like they've created a whole new playbook for managing data at scale.
Exactly. And I think another key takeaway is that these systems aren't static.
Right.
They're constantly evolving to meet new challenges and adapt to new demands.
So it's crucial to stay informed about the latest developments and best practices in the world of distributed storage.
So this is just the beginning of the journey for anyone who wants to master these technologies.
It certainly is.
Yeah.
And what a fascinating journey it is.
Yeah.
We've gone from the origins of these systems,
Yeah.
born out of the need to solve real-world problems at companies like Facebook and Google,
Right.
to the intricate details of how they achieve scalability, reliability, and fault tolerance.
We've also seen how they're being used to power a wide range of applications that we interact with every day.
Yeah.
From search engines and social media platforms to online games and mapping services.
And as we move further into this data-driven era,
Right.
the importance of understanding and leveraging these technologies will only continue to grow.
Right.
So for anyone who's been listening to this deep dive,
Yeah.
I encourage you to keep exploring, keep learning, and keep pushing the boundaries of what's possible with data.
That's a fantastic message to end on. And don't forget to check out the show notes for links to further reading and resources where you can delve even deeper into the world of Cassandra and Bigtable. It's been an amazing journey exploring these technologies.
It really has.
And we hope you've gained some valuable insights.
Absolutely.
As always, thanks for joining us on the deep dive.
It's been a pleasure sharing these insights with you and our listeners.
Yeah.
And remember, the world of distributed storage is constantly evolving.
Right.
So stay curious, keep learning,
Yeah.
and who knows,
Yeah.
maybe you'll be the one developing the next groundbreaking technology in this field.
Until next time, happy beta diving.